Let's do this thing.
Mr. Austin, do we have 12 levels?
You do not yet.
Okay.
So, we today are factoring to solve quadratics, which we have already done, in a way. Because we talked about this, but we never formally did it. That's bad. So, because I want you guys to have a lot of, well, not necessarily a lot, but I want you to have completely done examples in your notes. Some of the notes in chapter 12 are going to end up being like multiple pages, so just be aware of that as we move forward. Please try to keep track of them and use them on your homework because they are beneficial to, I don't know, you spending. Yes, they're good so that you won't spend as much time struggling. So, that being said, here's a completely solved example of the techniques that we've already kind of talked about. So, you have two of these. The zero product property, that makes sense because I should have one to put in here. The zero product property tells me that if I have a product, so anything times another thing, and that equals 0, one of those terms has to be 0, and or both of those terms could be 0. But either way, to make 0, one has to be 0. So I can break the terms apart and set them each equal to 0 independently, and I can solve that algebraically. So what we're really saying is this binomial gets set equal to 0 in one given situation. That binomial gets set equal to 0, and we already looked at that is actually going to indicate the points on the parabola where it crosses the x-axis. So if we try to write this out in an example here, let's try to got it. So split both of these into their own equations equal to 0. And although some of these are really easy to solve, it is easy to make mistakes. Now what's the trick if there's no coefficient to the x?
Well, there's always 1.
Well, okay, so if 1 is the coefficient to x, what's the trick with how I can actually just solve this really fast? Like find your x solutions. Michelle? So, yeah, she was saying you can solve these algebraically, -1 on both sides, add 5 on both sides. But really, if there's only a coefficient of 1 here, we can really just do the opposite of the values added. So if the coefficient's just 1, we really know immediately that we have a -1 and a +5. It's only once we have a coefficient to the variable that it really makes sense for us to work through the algebraic solution. Otherwise, we can just flip the sign and we're good to go. Because we already looked at, do you want to review why that happens? Because we already looked at it last week. So if we look here, we're still going to have coefficients of just 1 on the x because we just had x squared. So if we try to set this up, go ahead and set up your 2 parentheses. We know they both start with an x. And from there, what's our thought process? You can walk me through this. Okay? Yeah, so that's where we're going eventually. So you made this equal 0, and then this equal, you just kind of skipped a step. So we would, technically we break this apart into its 2 product pieces, the factors, yeah. So then what were they? They were x plus 3 and x what?
Not -3, +5.
X plus 5. Which then gives me my solution values for my x's are -3 and -5. And actually, what else would we know? If those are the values where it crosses the x, that actually indicates something else to us.
Oh, the axis of symmetry?
The axis of symmetry is going to fall
-4.
at -4, and once I plug that in, I can find my vertex point. And from there, a few days from now, you'll be able to find the directrix and the focal point and all these things that you don't know about yet. But they're very useful when we use parabolas in the real world.
That's what you're talking about.
Yes, we are all red pill or blue pill. Of course.
What I
Wait, what?
The Matrix. There's a point in the movie The Matrix where he has to decide what pill to take, whether he goes back to the real world and like forgets everything, or whether he like goes into the Matrix and learns the reality of everything. It's a really, really simple. Yeah, blue's to go back, right? Red is go to the Matrix. Red is what Neo chooses.
Right. If you go back, then you're not going to the real world.
You're going back to, but you wouldn't know. That's the argument. All right, factor this real quick on your own. Be careful of both of the negative values there. You're going to have to multiply to make a negative 14. But you also have to add to make negative 5.
I can see some drug treatment one, like sometime in the future, where they just like put your mind in a virtual reality, so you're there instead of here. So
You've not made it all the way through Black Mirror yet, have you?
you're, no.
Oh, I love
So
Drugs
there's-
get out of your system.
There's an episode
Is it
where
something like that?
that's like therapy for dementia type patients.
Oh yeah, I did see.
Yeah,
Yes, I
it takes
saw
you
that.
back from like
Yes.
the 50s or 60s.
Yeah.
Wait, was that the one where the girl, she's in like a very,
Oh,
she's
yeah.
in like a little pod and she goes to the beach with her girlfriend?
Yes,
Okay.
but that's like that's not reality. That's
Yeah,
a
that's like
virtual
their
world,
like Matrix.
Yeah, essentially.
I watched the one episode that you started from when you did. That was kind of messed up.
Yeah.
One of my favorite ones is when they put that woman's like mind in a little egg.
Oh yeah, and she freaks out about it. And then,
Yeah, that was so complicated.
I might have fallen asleep on that one.
The best one.
Dude, it was over winter break.
it's really messed up.
All right,
What's-
Strickland.
Black Mirror.
We start with M and M.
Okay.
What are my constants that happen in them?
I don't know.
So factors of 14.
I got 7 and 2.
7 and 2, let's try that. 1 has to be negative and 1 has to be positive. So if 7 and 2 are going to work, which one wins? Or which one has to be the bigger? The negative 7 and the positive 2. Does that work?
Yeah.
Winner, winner. Good way to screw it. Now, we can either set up my two equations, or because I only have a coefficient of 1, I can easily tell my solution values are negative 2, positive 7. Just flip the signs on your constants. Any questions?
And that's how you find it.
If the coefficient on your variable is just a 1, because think about it, this would be set equal to 0. I'd have to subtract 2 on both sides. It's always going to do that. It's always going to flip the sign. But once we have a coefficient, then we have to do that, the subtraction or addition, and a division or multiplication. So that makes it slightly more complicated. We could set up the equation, solve it algebraically, or mentally process through it, but we're still solving it algebraically. Estes is down here. We'll take care of it eventually, hopefully.
T-Rex.
So now, as I said that, I was like, oh, maybe he won't. Now that we have the 4x squared minus 21x, we are not quadratic yet. Because to be quadratic, we need to get into ax squared plus bx plus c form equal to 0. We're not equal to 0 right now. So what do? So this becomes 4x squared minus 21x minus 18 equal to 0. We are now in proper quadratic. So if we look at some things that have happened to the graph, it's been shifted vertically, assumedly down, but it's also been shifted left to right, which plays with how the vertical shift happens. And it's been like magnified or intensified, or its slope has been adjusted. So a lot has happened. As we factor it and work backwards, we can figure out every single thing that has happened. All the shifts, magnifications, everything. So if I break this apart, problem here is I have options. What are the options that I have? Caleb?
2 and 2 or 1.
Yeah, the 2 and 2 or the 1 and 4. You think 2 and 2 does not work? And we can sometimes as you get to work with quadratics more, you can start to recognize based on your B and C values whether I want those coefficients to be close to each other or whether I want them to be far apart from each other. So if Michelle says 2 and 2 don't work, let's try 4x and 1x. Anyone think of some factors of negative 18? Because as soon as I choose those, I just move right over to factors of negative 18.
I know.
Scrabbler, we haven't talked yet today.
9 and 2.
Not-
9 and whatever.
Now, here's the trick here. With these, I got to choose specifically where I place them.
You know you are right.
So where do you want me to put them? Because let's play out options. If I do negative 9 and positive 2 here, this will be a negative 36 and a positive 2. That's not going to work. If I do negative 9 and positive 2 here, this will be a negative 9x and a positive 8x. Well, that would only be a difference of 1. If I do, well, then I can't use those as my factor or as my constants. Carmen, give it a shot. 3 and 6, what do you want where? And what's positive, what's negative?
Alternative. I haven't tried it. At least it would have to be.
So the negative has to win out, right? So as we think through this and play with this, look at when I add my outers and my inners, the negative has to win out by a lot. So if I start playing with, let's try a negative 6 here, and then a positive 3 there, my outers give me negative 24,
That's what I was
plus 3, there's what we want.
That was my alternative after this happened.
And guys, you can honestly do this and just kind of sketch on your paper until you find it, because then all we care about is setting up my equations that are equal to 0. So I have 4x, what do we even decide? Plus 3 equal to 0, and we have x minus 6 equal to 0. So my x minus 6 is easy to solve. That gives me a potential x value of 6. Michelle? Negative 3/4, because I would subtract 3 from both sides, and then I would divide by 4, giving negative 3/4. Any questions? So that line of symmetry is going to be a bit more awkward to find, but we could still do it just as easily. Average out your values. Yeah.
We used to do the same thing we did last time, except adding like X thing on it.
Adding the coefficient, which gives you one more step to solving for your x. So if you want the shortcut, which is dangerous to use immediately, but you can look at your, let me capture this really quick. So we end up with 4x plus 3 and x minus 6. So we know here I can just flip the sign, and that becomes a solution value of plus 6. But here, flip the sign, divide by the coefficient, and you have your solution value. So, and that'll always work. So if this was like 8x plus 7, negative 7/8. So try the got it, which actually is easier because it doesn't have a coefficient. But you have to first put it into quadratic, and then, did you say you don't like it? So, as frustrating as quadratics are, this is kind of where I started to look at math as like a puzzle. Like, okay, so I have the pieces. I know what I'm supposed to do. I've got the picture on the box. And I just have to figure out how it all goes together to make what it's supposed to make. And I can put the pieces together and mash them in there and it just won't work right. Or I can work through the process and figure it out.
How are we going to use this in practice?
There are practical applications right here. And actually there are a lot more practical applications of parabolas than you realize. You just have to get through the like, how does it work to be able to do anything. And what? Yeah, and we throw things. Which actually, if we can figure out a way to calculate the upward velocity, the problem is my potato cannon isn't consistent. I need a trebuchet or a catapult. We need something. No, so I tried to show you the video last week, right? Of Wes's trebuchet. And the internet might be better today. But when you can do something that has constant force, so say it was an air-powered cannon, and you always had a certain amount of air, or catapult that's spring-loaded, that's always the same springs or always the same tension, you can calculate exactly how far it's going to go. And without knowing this, that's what a lot of ancient militaries would do with their catapults. They'd figure out in practice how far does it go, how big is the rock that we're using. They used parabolas to kill their enemies. So, not that they actually did the calculations, but without knowing it, that's what they were figuring out.
Wait,
Yeah.
so in Florida, there's this one like 4, and it has cannons on the top, and they've like fired down at the ships that
Yeah.
are in the bay. Would that also be like a problem?
Yes.
Because it would not,
Anything with gravity.
it would not be a straight line.
Oh, so that if it's not a straight line, that makes it a parabola.
I mean, it's going to have parabolic effects because of gravity. You're not going to see a whole parabola, but it will have effects of the end of a parabola. Problem is, you never reach your max point.
Right.
So if they didn't know that and they aimed the cannon at the ship, they'd miss. Unless the ship was coming in at a rate that compensated for the drop of the cannonball, but it'd have to be booking it. Like the ship would have to be moving pretty darn fast. I don't know. Shall? Yeah. Guys, back up here, please. So since we see that this is actually twice 7, 7 squared, we know this is a perfect square quadratic. Now, so wait. If that's the only one that we have, and one of them needs to be 0, well, then both of them would then be 0. What's my value of x here for the solution? Strickland? -7. So, well, there's no +7. But these are identical. So, hold on. So, what does that tell me about the parabola? That is the vertex. So, this is where we start to see how we can figure out what has been done to the parabola. When we see that there is the +7, that is actually indicating that what happened? It was a horizontal shift. Yeah, I'm abbreviating horizontal. I said it. You know what I mean. Glenn? Because to bring it over here, algebraically, we had to add 49 to both sides to get that right side equal to 0. Because to be in quadratic form, it's got to be equal to 0. Because what we're solving for is where does this equal 0? Where does it cross the x-axis? That makes sense? So you can put it in different forms, but then you're not solving for where does it hit the axis. It's just kind of a different form that is not as useful for us. So that tells us we've had a horizontal shift, 7 left. So from our parent function, from just our function x squared, because that's our parent function, we've now got a shift 7 left. Because that horizontal shift, and I'm teaching ahead of where we are, but I want this to be introed so you guys understand it. That horizontal shift squeezes in with the x before the square ever happens. So if we go the other direction, instead of solving it from the quadratic, if we build it from the parent, I would start with my function x quantity squared. That's my parent function. Then to move it in here, I add the 7. Now here's what's really interesting. To do the vertical shifts, that would be like out here after parentheses. So we're going to get to looking at this tomorrow. That's as much as I'm going to go into it today. But horizontal shifts happen inside. Vertical shifts happen on the outside. So you don't need to know that yet. I just wanted to intro it so it starts to marinate in your brain.
I'm pretty sure we already learned that last.
Good.
I kind of forgot it though.
That's why math builds. We always keep circling around to talk about what you already know and how we can use it to do cooler things.
And the only reason I remember that is because I was helping someone with their homework.
Yeah. So here's where it can be used in a real world application. Say you go to a frame store, and yes, there's millions of dollars in putting frames around things. Joanne Fabrics, if you've never been there, has an entire wall full of framing choices. Yeah. Why am I hanging out in Joanne Fabrics?
Well, not
Yeah,
really.
that.
I mean, yes, sort of. But
It is a really cool store. Thank you.
See,
But,
this
like,
one I'm not
Does it
gonna
have
how
buttons
much?
on?
How much do you think the frame costed on like the Mona Lisa?
A lot.
I don't know, but probably a lot.
No, no.
Well, so originally it wouldn't have had a frame.
Yeah.
When you make a painting,
No.
you either make it on stretched canvas or you put the canvas around your frame already. Yeah. So the frame comes after. The artist doesn't care about the frame. Normally, the place showing the painting chooses the.
Why do they have a bunch of frames? It
No, because they want to preserve it.
So once you choose a frame, you normally like stick with it.
Because you don't want to lose any damage paint.
Sometimes there's hidden stuff like around the frame where the art they painted not hidden, but it's painted around the canvas as it wraps and you can't see it.
Conspiracy theory.
Mm.
What?
So
I'm trying to convince Mr. Beck to do conspiracy. I want Mr. Estes to do.
Wait, Mr. Hudson.
I'm pretty deep into that realm too.
Are you still doing your one game classes, people?
Please.
Debating.
No, please.
But-
Please, I didn't get to do it last year.
It was the best class
I
last
didn't
year.
get it last
Oh,
year.
okay.
I don't get it, I'll get stuff.
Okay.
That's on video.
Okay, we'll do it. Okay.
Oh, wait, I have a question. Are you gonna make an Instagram?
I just had no time. I haven't even re-downloaded Twitter on my phone.
Nobody uses Twitter. Everybody uses Instagram.
I have to have one for school. Can we move on? I want to give you guys time that we can all work on our
Oh,
own.
yeah, and then you can look up the future. Oh, sorry.
So, what we know here. This frame, to be aesthetically pleasing, is going to be the same width all the way around. Otherwise, it would look totally wrong. Although the width and the height of your picture are not the same, your frame needs to be the same, especially so you can make 45-degree angles on your corner. But even that pattern, like a wavy pattern, that wave would be the same width the whole way through. But imagine we're doing a simple, square, straight frame, 45-degree corners, same width all the way around. But we don't know what the width is yet because we have not picked our frame. Now, what we do know is this needs to cover up a safe that we have in the wall. Now, that safe has a front face area. What? I try to make these problems more interesting.
That's nuclear.
Of 315 inches squared. So that picture needs to perfectly, like in the movies, cover that safe. So we need to figure out how big of a frame do we need. And of course, if this was a realistic situation, that'd be the minimum size frame. We're trying to cover that safe. So we need to first figure out, well, what is the area of what we see? Because we know what the area is supposed to be. But if I really look at trying to calculate my area, now this is going to be a really dumb question to start. How do I find the area of a rectangle?
Length times height.
Okay, did you say pi?
I said height.
What's my length?
Well,
What? 17 plus 2x? I'm starting with 2x because, trust me, we would rather do that. What's my width? Or height, or whatever you want to call it. 2x plus 11. Hey, we're going to build a quadratic here. Now this needs to equal 315 inches squared. So, just so it's been said, so we assume this is inches, that's how we get our inches squared. But I'm not putting labels in. So when we FOIL this, our firsts are going to give us 4x squared plus, what's our outer give us? I'm going to write these over to the side. We'll write them down here. What's our outer? 22x. Inner? 34x. 17 is always fun to work with. Last? Break it up. Yeah, because we can do 17 times 10, and then one more 17. So 170 plus 17 gives me 187. Ah, yeah, okay. Very cool. So, we have a couple things we have to do here. Is this in quadratic form? No. Are there like terms to combine?
Yes.
So, do all that. That's weird. 128. I was about to write it down and start borrowing. I just hate borrowing. That's why I buy my own things to borrow. So, this is tough. Right? Because we have choices on how we factor 4x or 4x 1x or 2x 2x.
Factor out the 4.
We can factor out the 4 to begin with. I can't tell you how much wasted time has been put in from anybody in the world not thinking about factoring out the 4 first. Because does factoring out a 4 affect my solution points? No, because that 4 would then have nothing to do with the x. So if I factor out 4, I get x squared plus 14x minus 32. I'm going to capture. So now, really, all we care about is this, which makes us a whole lot happier than 4x plus 56, or 4x squared plus 56x minus 128, because that makes me sad. I would not want to factor that guy. So what terms can we use for our constant here to multiply and give us a negative 32? Caleb?
You can use
Now hold on. Did you plug this in and make your calculator solve it?
No, I didn't. No, I didn't do that.
You keep the
messing with
history,
this
I
thing.
saw him.
I've been doing that periodically. No,
Oh yeah, my
No,
science joke.
that was.
How
Okay.
was a shirt like that?
I do too. I have a periodic. Okay, so anyway, so 16 and 2 because
Ooh. So which is which?
so 16 has to be positive and 2 has to be negative.
Which
Wait, I
means
can
my
actually plug this in and solve it.
solutions.
Wait, really? Wait, you're not kidding when you said I can plug this in and solve it?
You could have plugged in that guy and solved it. I'll show you in a second.
Stop
Oh, heck yeah, dude.
What are my solutions?
X equals 2 and negative 16.
What's dumb about this? Can I have a frame negative 16 inches wide?
No, it's 2.
So I throw away the solution that doesn't make sense.
Oh yeah.
Does it matter?
Seems like what?
No, it doesn't.
So here's the question.
Divide both sides by 4. And
So Caleb, when you said like, wait, are you kidding? I can have my calculator do this?
Yeah, dude.
Ethan, what do you get?
Desmos, I need to bookmark this. So we had, hold up, we had 4x squared
Oh yeah. Look.
plus
I think it's about like both.
56x minus 128 was in quadratic form, right? So if I zoom out, there's my 2 and negative 16. Because if I factor out the 4, and I only have x squared plus 14x, look at what has actually happened with the difference in these two graphs. What's the only difference in my two parabolas?
One went down. So
The steepness of it. When I change the steepness of the parabola, the intensity or magnification or whatever you want to say, the zeros are not affected. So factoring out that 4 just makes my life easier, and I don't have to bring it back in because my zeros have not been affected by the difference in parabolas. Now, if you want to go one step further, and maybe, I don't know, you guys might think this is cool. You might think this is cool. Maybe. So here's my two graphs of x minus 2 and x plus 16. So what has actually happened is these two functions have multiplied by each other and they make the parabola. Because that means those are my two solutions, like my two factors that will work. Yeah, Calvin?
Max brought this to my attention. Another reason you can just get rid of the 4 is if you really want to get rid of the 4, you can divide both sides by 4.
And what's 0 divided by 4?
0.
So when we factor out 4, it doesn't matter anymore because dividing by 4 to 0 does nothing. Not yet, very clear. Try the got it on your own. They have made it easier. The numbers work nicer, and it is still the same. It's the same function to start. It just equals a different area. So notice it's the same picture, same function to start. It just equals a different area. So we can set up our original 4x squared plus 56x. But we have the plus 187. So if you're going to start with something, go back to where you had the plus 187 and make that equal to 391. You should get to there when you would take your two binomials and multiply them by each other. You get the left side, the right side's the area. Oh.
Totally not gonna like use it.
Yeah. But if a test lets you, why not? So you went to your right and plugged in. Well, what do you get when you do 187? So if we do 187 minus 59, we have to make it quadratic, right? So you negative 204. So now this is going to be 4x squared plus 56x minus 204. That then will graph it, although not very effectively because my window is way not correct until we see some of it. But I can do second calc and use 0. My x is 0 when y equals negative 204. Sorry, no, so now I'm guessing. So my x equals 0. Well, I can't see it right now. You want to zoom, try to zoom fit. Well, most of the time zoom fit does not really work that effectively because it does something like that. So, yeah, I need to go way further on the left, so if I adjust my window again to make my x a little bit. So now, if you wanted to tell you where your zeros are, hit 0. You say you're tracing now. Left bound, right bound, just like we did for the max. Guess it. Have a 0 at -17.
On that side. Oh, I just see complete cheating.
And I come over here. And now I'm down this kind of far because of
Oh,
I did.
So what you see from that is with the 4 factored out. So if you use your calculator to get these, what are the binomials that you would have? Yeah, the x.
Oh, what? That's like cheating, dude. That's like ridiculous.
So. We have like 5 minutes left. When we subtract on both sides, you should have gotten to a point of this. And when we factor out, you would have gotten, actually I don't know that one. Still your 14, but then this is, that number has been ruined. Are you sure?
51.
I was about to say 21 doesn't work. Then, I know this because of what Caleb and I just did. My binomials would have been that. Because in your calculator, and again, I'm kind of teaching you further than we need to, but then it helps us move more quickly in the future. Not fun. What do I like this? Check. So this is where, because I can't have Caleb say, well, that just seems like cheating, without showing you guys what we're talking about, because that just doesn't seem fair.
I do it on this calculator, it's like cheating. I do it on this.
Yeah, you can do it on any of these calculators.
Oh, dang, oh my
So you don't grab a calculator right now. I'm not worried about you doing it right now. But if I took this or this quadratic, either of them, and I'll take the more complicated one so I don't even have to think about factoring. So if I took 4x squared plus 56x minus 204, right? I want to tell that to graph, and my graph's not that happy because my window is totally screwed up. If I zoom fit it, it will try harder to make a window that works. Now, Caleb's calculator was much better at finding an appropriate window, but if I care about the zeros, I can start to figure out my window, because right about there, so I need an x of like 7-ish. So I can really leave my x at a positive 10, but I need to make my negative probably something pretty big. So let's try negative 30, and a positive 10, we'll make that 4, and my y is kind of crazy right now, so let's just do 300, and maybe like 300, and try that. Hey, look. So, all I have to do is get to a point where I can see where the parabola crosses the axis. Now, one of these calc features, so second calc, the second one that we haven't used is 0. So, if I want to find my zeros, this will start tracing somewhere. Notice that it tells me where I'm tracing. I'm at negative 3.19 whatever. Seems like I'm too close to the axis. If I come away from the axis, now I can see where I am. I couldn't see because I was too far down the parabola before. So if I hit enter, do my left bound, right bound, and go closer and guess it, I get my 1, 0 of negative 17. If I do that again, now I have to actually select the function again, which is kind of annoying, and go all the way over to the other side of the parabola. Thankfully, we can hold down the button. Yeah.
Couldn't you have left the window as it was when you started, since you don't need the negative solution in a real world situation?
Yes, but I'm trying to just show you, like, in any parabola. Because you will use this in, first off, non-real world situations, just problems. And you'll also use it in other applications where you might need a negative answer as a potential. So, I just wanted to show you guys how to find zeros. So, and adjusting the window is just one of those skills that come better with practice. Yeah.
Should we buy a graphing calculator for high school?
If you don't own one, you're gonna end up buying one. The only thing that I would be cautious on is how much technology has progressed / is progressing, and what your alternative options are. If you end up in high school and they say, "Oh, if you have a graphing calculator, great. Otherwise, you can download this app," sort of thing. But I don't like making my cell phone the only thing I use. I like a physical standalone calculator. If I was you, I'd buy an 84C. So this is an 84. It does everything you'll need to do in high school. This has a clear, crisper resolution, rechargeable batteries, and it's color. Rechargeable batteries are going to make up the difference in cost because you'll use this enough in high school, you'd run through packs of batteries. This, you plug into your computer, when it goes dead, overnight it's charged.
So it doesn't have that solar thingy?
No, but neither do any of these. Graphing calculators take too much power to run off solar.
What?
Yeah, dude, they take 4 AAA batteries.
Those are the small ones.
They are the small ones, but they're expensive. Alright, so that's how we use a calculator to find zeros, and that's all the time that we have for today. So tomorrow we will pick up right on problem 5 then.
So are we doing homework?
I will pass out the homework to you guys.
No.
Do as much as you feel like. Obviously, I'm not going to be collecting it for a little bit. Let's do evens odds. And obviously, there's an or in there. Let's do evens and odds. What? No. You guys want suckers?
I would
Yes. Oh, you want to or and I'm going to go charge interest.
Oh yeah, the interest rate. That's what did it.
Half of soccer.
All right, come here, guys.
charge interest.